Ryan, as requested by you, here is the solution of question number 10, page 372 from Nelson Advanced Functions. The question is, the number of tons of paper waiting to be recycled at a 24-hour recycling plant can be modeled by the equation P of t equals to 0.5 sine pi over 6t plus 4, where t is time in hours, P of t is number of tons waiting to be recycled. Use the equation to estimate the instantaneous rate of change in tons of paper waiting to be recycled when this rate is at its maximum. So the critical point here is to find instantaneous rate of change when this rate is at maximum. Right? And I think that is the point which you need to understand. So we are given a sine function here, and we'll figure out at which point on this sine function are we expecting maximum instantaneous rate of change. So let's try to sketch this first, and then we'll answer this question. So let us say that the sine function, so what I will do here is I'll sketch a part of it. We have axis at 4, so let us say this is the axis at 4, and the function has amplitude of 0.5. There is no phase shift, it's a sine function. So we can just sketch the sine function kind of like this, right? So of course the amplitude being 0.5 and this point is 4 for us, we have 4.5 will be the upper limit and the lower limit will be 3.5. Now time period for this function should be 2 pi by k. K is pi by 6. Pi by 6, so that gives us 12. So this is 12 for us, so this point is 6 for us. So that is the sine function which represents this equation. Now, what is the point where we are expecting maximum instantaneous rate of change? Can you answer that part? It is important to understand that that point is a point where the concavity changes, and it is this point. So maximum instantaneous rate of change will occur at a point where the concavity changes. That is critical to understand. Now for this function, as you can see, the concavity changes right there. Now it is going to be negative if you draw a tangent here, but we are actually interested in absolute value, right? So that absolute value is going to be maximum. So that is the point, right? Now what we are going to do here is we will find the maximum rate of change by selecting 2 points close separated by 0.25. So we say instantaneous rate of change for this function, we can write this as f of 6 plus 0.25 minus f of 6 minus 0.25, which is 5.75. This is 6.25, and we can write here as 6 plus 0.25 minus 6 minus 0.25, correct? So that is what will give us the instantaneous rate of change where we expect it maximum with centered interval of 0.25 on either side. So we are using centered value, right? With delta 0.25, the change as 0.25. So let's calculate the value. So what we have here is we have 0.5 sine of pi divided by 6, and t we are saying is 6.25 times 6.25 plus 4 minus 0.5 sine pi over 6 times, if I take away 0.25 I get 5.75, let me write it in brackets, plus 4, okay, divided by this minus this, which will be 0.50, correct? Now we can use our calculator and find this answer. So we have, let me write here, 0.5 sine of within bracket pi. So I'll first multiply by 6.25 and then divide by 6 bracket close equal to plus 4 equals 2. So that gives us 3.9347 minus the other value is 0.5 sine of within bracket pi times 5.75 divided by 6 bracket close equals to plus 4 equals to 4.0652. 4.0652 divided by 0.5, correct? So we'll just take away one value from the other, and actually we are looking for positive instantaneous, so let's take the absolute value of this. Okay, so we'll take the absolute value. So let me take away 3.9347 from this and then divide by 0.5. So what do I get? 0.2611. So what I get here is 0.2611, right? So that is the change, right? So it is tons per hour, so it is T per hour, that is the unit. So that is the expected maximum instantaneous rate of change for this particular function. And of course, if you kind of decrease this interval to 0.01 on each side, for example, then you get more accurate result, right? So that is what I hope it helps you to understand the concept, and I can expect what was the main problem. The main problem is the point where you wanted to find instantaneous rate of change. I hope that makes it very clear. Maximum instantaneous rate of change will occur at a point where the concavity changes. I hope that helps. Thank you and all the best for your test.